Extendable hashing comes in handy when we are storing data records on the disk. The discussion of extendable hashing follows directly from the discussion of collision resolution. So assume that we want to store n records on the disk, and also we are not allowed to store more than m records in a single disk block. We would like to come up with an algorithm that will find what you are searching for without examining more than 2 disk blocks. So the idea is to group data records such that records with the first n bits the same are stored on the same disk block. So we do the grouping accordingly. If some block becomes full and we want to add more records, in that case we will have to split that block into 2 blocks. But in that case, we will need more than n bits. Actually, we will need n plus 1 bits to find the correct disk block. So, as an example, let's assume that we have 4 disk blocks, and in each block we can contain up to 3 records. Since we have 4 disk blocks, we will be forming 4 groups, which we can do with 2 bits. So we use the leftmost 2 bits of each record, each key actually, to find the correct block. So as we said, we have 4 blocks, 0, 1, 2, and block 3. So all records in block 0 have their leftmost 2 bits evaluating to the value 0. Those in block 1 have their left 2 bits equal to 1, 2, and 3 accordingly. Now, assuming this scenario, now let's try to insert the key, the record with the key 01011. Now, we look at the first 2 bits, 01, so it falls into disk block number 1, but there are already 3 records in it, and remember that according to our assumption, we cannot put more than 3 records on a disk block. Inserting this one here would cause having 4 blocks. So what we do is we split this disk block 1 into 2 blocks and distribute the records in these 2 blocks. We do not want to touch the others at the moment because the change we're making, the insertion we're making, is expected to affect only this disk block. So what we do is we create, as I said, 2 disk blocks. Actually, one of them is the previous one. We're adding a new disk block, but this might need also some elements to be shifted. Let's see. Now, first of all, the numbers of these 2 blocks should still start with 01. Okay, as you can see, we have 010 and 011 disk blocks now. So everything that starts with a 010 is placed in this disk block, and those that start with 011 are placed in this disk block. Note that the first 2 elements here are the ones that were previously here. Earlier we highlighted only the leftmost 2 bits. Now we are highlighting the leftmost 3 bits because we are now using 3 bits rather than 2 bits. Also realize that the new item to be inserted, which was supposed to come in here, really gets placed here. This is the last row, and it's in the last row here. However, the element 01100, which was earlier here, gets moved to this new block that we have created. And the reason for this operation is we are now, as I said, looking at 3 bits and the third bit here. Now, the first 2 bits are the same for all because they were in the same block, but the third bit here is 1, whereas the other 2 were 0. That's why this element has to go to this new block, which starts with 011, and the new one that gets inserted starts with 010. That's why it gets inserted to the previously existing block. But note that since we're using rather than 2 bits, we are now using 3 bits to identify the disk blocks. We should do the same also for the other blocks. But earlier this was only 0, 0. Now when you would split it, when you consider one more bit here as a third bit, that could be either a 0 or 1. So those two cases, 0, 0, 0 and 0, 0, 1, are together here. They map to the same block at the moment. Why? Because I have only 2 elements here. I don't need to create an extra block just because I needed to split the other block. So these two values will map to the same block because at the moment this is sufficient. Having a single disk block here is sufficient for these 2 separate keys. Similar is true for 100 and 101, and also for 110 and 111. So at the moment, earlier I had 1, 2, 3, 4 disk blocks in my system. Now I have 1, 2, 3, 4, 5 disk blocks. But I can survive with this, with these 5 disk blocks for a long time because I have 2 available positions here, one here, one here, and one here. I will not need to split these further for a long time as long as these 2 places do not get used. So the size of the directory here, our directory is these 4 disk blocks, and here it was 5 disk blocks. So these are called the directories. The size of the directory is 2 to the d, where d is the number of bits that we're using. So earlier it was up to 4. Now when you make it 3, it's up to 8. I'm using 5 of them at the moment, but it allows growing up to 8. So the maximum size of the directory would be 2 to the d, which is of the order with big O notation, n to the power 1 plus 1 over m divided by m, where n is the number of records and m is the number of disk blocks.